Hello and welcome to the Rubber Duck Dev Show. I'm Chris,
I'm Kristen.
and tonight we're going to be talking about static versus dynamic typing for languages, mostly specifically for Ruby and the things they changed in 3. But before we get to that, a couple of little house cleaning things. First, if you've been enjoying the show and you want to help the channel, please do mash that like button. That's one of the biggest, easiest things you can do to help us out. The other thing is, both of us are feeling a little bleh tonight, so there could be some coughing going on.
And I look bleh. I look like bloody Casper. Look at me.
we,
I got a halo around me.
we think somebody's white balance may have gone a little goofy on his camera, but discovering that 5 minutes before the stream, we'll live with it. It's fine. It's cool. Half of you people listen to the podcast anyway, so you can't even see it. So, also,
sorry, I broke your train of thought.
what am I doing? I'm old. Don't do that. So also, crap, I don't know. What are we doing? Oh, week in review. Here we go. Yeah. So how was your week?
Well, it's actually been 2 weeks because we missed last week. And the reason we missed last week was primarily because I got the disease that shall not be named, or they take off your YouTube videos. So, yeah, so I was dealing with it. I'm still dealing with that. Still, I hope this is the tail end of it, of course, but that was there. But then before that, I had the unpleasant incident of saying, oh, it's time to update my computer and do a reboot. I used Ubuntu 20.04, the LTS version. And after rebooting some updates, it wouldn't come up anymore.
Eek.
And I use whole disk encryption, and it would never prompt me for the password. I tried going to previous kernel versions and it let me get in that way, but things weren't installed. The network wasn't working. I was going to basically be on a long road to get it fixed. So at that point, it's like, all right, I can go from backup, or I could go ahead and jump to 22.04, which was the newest Ubuntu, or Ubuntu, however you say it, has been released. So I could jump to that. So I said, all right, I think I'm going to go ahead and do that. So my Casperness, in the video today as a result of 22.04. I was able to get OBS working fine, but because we're using Zoom to do this recording, I don't know what's up with my camera. I Googled it and tried some applications. That didn't work. So I'm like, ugh. The other issue with, if you're considering moving to Ubuntu 22.04, for those of us who use Ruby, is that it bundles OpenSSL version 3.0. That is incompatible with every Ruby version prior to 3.1. So that means if you want to use Ruby version 3 or 2.7, 2.6, anything like that, you actually have to go and manually install a previous version of OpenSSL to be able to get it to compile.
Fun.
Yeah, so I tried, hey, a lot of my projects I couldn't upgrade because, they're customer projects and whatnot. So I'm like, ugh. So I had to do that workaround for a number of projects to get stuff working. So that was part of the fun that I was doing in and around when I was sick as well. But apart from that, actually am getting some work done now, doing some database consulting, as well as some more another payment integration for my product that another customer wants. So it's like, this is like my 11th or 12th payment gateway.
Oh my gosh.
It works with all these different kinds, but just this customers say, hey, can it work with us? I'm like, We can make it work with that.
Old hat now, huh?
Well, yeah, I mean, normally I used to say it takes 2 weeks to do. Now I'm kind of like a couple of days, 3 days. I mean, I don't tell them that. I still say 2 weeks, but
Yeah.
the actual amount of work is usually 2 to 3 days. And although some of these are very esoteric, because like I'm working with one right now where the documentation compared to something like, a PayPal or a Braintree or a Stripe is just, it's just not there. It's definitely not rich. So it's more back and forth of the people to get things done. Well, anyway, but that was an extended what's up with me. What about you?
Well, I actually had a really long week a long week and a half. We last Monday we did a deploy to one of our really big clients, and the next morning, and the deploys happen between midnight and 4 a.m. So I was already up well past my bedtime. But the next morning, things weren't going quite right. There was a massive slowdown in some of the sidekick jobs, some of the background processing things. It just went bonkers slow, and it took us a good almost week and a half to finally track down exactly what the issue was.
Ouch.
Oddly enough, the issue comes down to, and I hate to say this, if we had had a strongly typed language, this wouldn't have been an issue. So it's actually kind of weird that this happened the week that we're doing this show. So I do actually have something to talk about, a real world example of static versus dynamic typing.
Interesting.
But yeah, I'm very lacking on sleep because most of the research that we had to do and the experimentation we had to do to try to figure this out had to be happening between midnight and 4 a.m. So several nights last week, a lot of the weekend, last night I was up well past midnight, and you know, I'm an old boy that goes to bed at 10:30 or 11, so it's rough.
That's unfortunate.
Yeah. So anyway, all right. So with that said, let's talk about static versus dynamic typing. So let's first define that. What does that mean?
Well, I mean, static typing is you explicitly, I guess I'll say it's the difference between explicit and implicit. You're explicitly stating what a type will be for a particular variable. Like this will be an integer, this will be a float, this will be a string or whatever. Whereas dynamic, you don't tell it what kind of type it is. The computer system or the program that's running kind of infers what that type should be.
And that can change.
Right. Although there's some languages that allow are a little bit more strict. Oh, what's
Right.
the term? I can't remember the term. Like after the fact, like once it's established, hey, this type is this, you can't change it.
Right.
Like Ruby's that way, but JavaScript is more loosey goosey.
Right. And so the other side of that too is with strongly typed language. If I say variable A is a string, I've defined it that way, and I try to put an integer into variable A, it will blow up.
Yell at
It'll
you.
bark at
Yeah.
me
Yeah.
right then. With a dynamic language, all I have to do is say a variable exists called A, and then I can put whatever I want to in it, at least the first time. Some languages, you can put whatever you want to in it ever. Some of them, like after the first run, that type wins. This is now that kind of variable.
Yeah.
But So there are some differences in implementation and how errors are reported and how early they're reported in some cases. So both of us have been doing this a while, and I would say that I've had probably about the same amount of time with both typed or static and dynamic typed languages, strongly and weakly typed. I spent a lot of time in .NET, which is a strongly typed language. I've spent a lot of time in Ruby, which is a weakly typed language. I've done quite a bit of JavaScript, which is a completely untyped language, essentially. And I've done, C++, COBOL. Not a lot, but I am that old. And, Turbo Pascal and other languages. So I've spent a good bit of time in both of them. And it's what struck me as kind of funny when I was looking into things for the show is that, TypeScript is kind of the big brouhaha lately. Everybody's up on TypeScript because basically it's typed JavaScript.
Mm-hmm.
And now, with the Ruby doing the RBS and, typed Ruby, and everybody seems to be coming to this epiphany that strongly typed languages are the next wave. And I'm like, but those have been around forever. And I spent a lot of time trying to get away from them. So it's kind of funny how every time we do these kind of this versus this scenario, it's like we've seen this before, and then the pendulum swings to the other side, and then it swings back, and that just seems to happen with almost every this versus this thing in computer science.
Yeah, that's just the way it is.
But kids, this is not a new concept. Strongly typed languages have been around for a very long time. So why do you want to use strongly typed languages versus why would you want to use dynamically typed languages? What do you think?
So one of the main reasons that people are advocate doing it is it gets rid of a whole host of errors that can happen with the dynamically typed languages. Like, for example, you can get no method errors or type errors in an actively running language that you can just avoid those entirely if you're using a statically typed language. So that's one big reason. The other reason is that it helps you build better interfaces. Now, not a strictly interface, but whenever you're designing a class that has methods, the interface that you're working with for that method, it could be much more explicit if you're using some sort of statically typed process for setting that up. Meaning that if you're passing into a method something called account, well, is that an Ruby object? Or is that an integer? Or is that a UUID? Or is that a hash? I mean, you have no idea with Ruby, for example. Whereas if you're using a statically typed language, you can explicitly say, hey, this is, like an object or a hash or something like that.
And I have had some occasions, like in controllers and things like that, where I've had to say, hey, if this parameter is a hash, do this. Else, if it's a array, do this. And that's a byproduct of having dynamically typed parameters.
Yeah. And now what's interesting about Ruby's direction, I am not calling it statically typed Ruby, because what they're actually done with Ruby 3 is introduced the ability to do static analysis. So it's not that, in your Ruby code, hey, I can now say this variable will be an int or a string or whatever. You are describing in some way your code, and then a static analysis tool checks that against your code to say, is this true? Is this true? So for example, like what Ruby 3 offered is these RBS files. So these are files that are alongside your Ruby code, or sometimes they're stored in a specific directory. Now, I've tried to look up what RBS means. The best definition that I've seen, or one that was a little bit more explicit with it, was Ruby signature. So it's supposed to be RB for Ruby and S for signature. So it's like a signature file that kind of defines the structure of your program. Although I guess it could be called Ruby structure file too. So RBS could be Ruby structure. I'm not
Well,
sure.
my brain kind of equated this to like an XML schema file, kind of a definition of what this thing is supposed to look like, but it's not the
Yeah.
actual thing.
Yeah. So, and what this basically does is enables a static analysis tool to then check your types, or to say, hey, do you have a method that you've implemented that is not reflected in the RBS file, for example. Now, I mentioned two reasons why this is of interest. One is getting rid of things like no method errors or type errors. The other one is better interfaces. A third benefit is that if you're able to use like code completions for IDEs. So it's able to, if you use a certain like IDE, like I guess Visual Studio may have some plugins for doing it, it enables you to do more code completion. Now, that's something that I had in when I was doing some .NET stuff that, I've never had with Ruby. So that is something that is a bit appealing if that could, truly work. Now, so that's kind of like the why for. Do you have any additional things you had thought of?
No, that kind of covers what the benefits are of static typing.
And I think why you hear it about the big Ruby projects that are using this or have used this or using other solutions to it is to get rid of errors.
Right. And
That's the main reason.
yeah, and one of the things you talked about is that like the RBS implementation is more of allowing like a linter or a static file checker to go through and say, okay, this is what it's supposed to look like. Does your code look like that? Let me check. And to be fair, that's kind of how things like compiled languages like .NET work, because you define the structures. Now they're not in a separate language. You define them in line, the typing. But it's not until you go to compile it that it goes through and says, whoa, this is not the right type of variable.
Yeah.
Now
Yeah.
the
And I'm used to,
IDE, like Visual Studio, will give you some hints and say it can know, hey, you've defined this as this and you're assigning this thing. This is probably not okay. But it doesn't actually give you errors until you go to compile it.
yeah. And I'm accustomed to that compiling stuff like with using Elixir, because that compiles into the Erlang virtual machine language. So yeah, I'm used to getting certain set of errors once at compile time and then hopefully avoiding things at runtime.
Right.
Okay, so now kind of how this works, at least for Ruby, is that so again, there all are these separate files and they went this route because I think it's similar to how TypeScript works in that you have separate TypeScript definition files that are independent of the actual JavaScript. Well, it's the same way with Ruby. You have your normal Ruby files, but then you have these separate RBS files. And they did this so it can work alongside and you don't have to change any of your Ruby code. So your Ruby code ideally just stays the way it is, but you're just adding these additional files. And how you do it and what they released in Ruby 3 is an RBS tool as well as TypeProf, which are ways you can generate signature files from existing Ruby code. So basically, you have it analyze a piece of Ruby code, and it will give you a prototype definition. Probably a lot of it is going to be undefined, the types. So you need to then go in and manually fill out the types. I kind of think of it as like a Rails scaffold. It gives you a scaffold to work from to start filling out.
Yeah.
So that's kind of how it works. Now, there are other static analysis tools that are used. One of them seems, I think, probably the most popular one until Ruby released this is Sorbet. And what that does or uses is inline type signatures. So right above your method definition, you say like sig and you define what the types are. Now, I hate to say it, but personally, I kind of prefer an signature inline above a method as opposed to having to maintain a separate set of files. But that's just me.
No, it's not just you. There's at least two of us that prefer that.
Yeah, because as I'm looking at this, I'm kind of like, I got to be having. I'm coming early with a verdict here. I got to have a ton of no method errors and type errors for me to want to implement this thing, because you talk about test driven development. Oh, now you're doing things duplicate. Well, I'm looking at this as like, now this is triplicate. So I have to maintain my code. Now I have to maintain these type definitions, and then I have to do my tests. I'm kind of like, that's expensive to maintain, in my opinion.
Right. Well, if I were to have to do static typing, I would much prefer the sorbet concept of having an inline, because I don't context switching. Oh, okay, here's this definition. I'm researching this issue. I'm troubleshooting. Well, let me go to this other file now to find out what this is defined as, instead of I can see everything right here. That really is annoying, and it slows you down.
And then, yeah, and you have to go and reference it and find it in the file. And it's essentially an identical specification to what's there. It's like so much has to be copied over.
Right.
Whereas really what's different from your implementation is just saying what type something is.
Yeah.
And that's just so frustrating. You have to build this whole file, replicate your structure in order to just have this one additional piece of information.
Yeah, and you're right. That doesn't, to me, that doesn't make a lot of sense. All that's going to do is slow me down, bloat my code base, cause me to have to look at yet another thing to try to troubleshoot a problem.
I mean, frankly, I wish they would have. I would have welcomed having to change my Ruby code as opposed to this, meaning that if I wanted to implement static typing for a given file, let me put a magic comment at the top, for example, and then now I know I need to do typing in all the methods in that file or whatever.
Right.
I would prefer that as opposed to this half. Well, I don't like it.
Yeah,
I think it's half a solution, unappealing solution to me.
I generally don't either. And Mark Clifton says, welcome, Mark. Type errors, that's what test cases are for. That is true, generally. However, to be fair to the people that like strongly typed languages, let me tell you a story about where that would have saved me a week and a half of work. So this issue I was dealing with for all of last week was the fact that when we did a Rails upgrade on one of our parts of our system, it caused a lot of gems to be upgraded, to need to be upgraded. One of those was an internal gem that the team that was dealing with that actually had to change the signature of a method, or it had to change what it was using the parameters as. So it used to be that we would pass in an actual model object. What they had to change it to was a string, to reference as a string. So they just changed the code to work as a string, as that parameter being a string, but they didn't change any checking or make any checking to say, hey, if anybody's calling this and hasn't changed this, we're going to throw an error. So what ended up happening is there was it had to do with cache invalidations being blocked during certain certain processes, because of Sidekick and Redis jobs going off, and it stopped blocking those cache invalidations. So we had 100 times more cache invalidations popping off than should have been, which was hard to find in the first place. But then to find out why that was, we had to go hunting through these other repos and find this gem that had gotten changed, and the test didn't pick it up because what the test was doing is ensuring that we were calling that method. So even though they changed what the method was doing, we were still calling it, so the test passed. But because it wasn't strongly typed, the test didn't know that it wasn't supposed to be passing an object in anymore. So this got all the way through testing without having a problem, because it's kind of a hidden error that you wouldn't see until you got to scale. So in that particular case, having a strongly typed language would have caught this before it ever got out of development. Now, on the flip side, I've been programming in Ruby for almost 2 decades. That is the first time I have ever run into a situation where strongly typed languages would have been a preferable option. The first time in almost 2 decades of Ruby where that would have made a difference in the positive. So I just have to say, it's such a rare occasion that I'm not convinced that it's worth all the negatives associated with strongly typed languages. And I have seen, with the .NET stuff, I have run into all kinds of issues where somebody changed a type and it just broke everything. And it was a royal pain in the butt to try to track it down, because they changed it from an int 16 to an int 32. Ruby couldn't have cared less, but .NET just bleh, and it just became way more trouble than it's worth. Plus, having to figure out what type this variable is going to be specifically causes you to have to do a lot of thinking that you shouldn't need to do when you're in the middle of your test write refactor. You don't want that feedback loop getting interrupted with a whole lot of thinking about, okay, if I make this an integer, can it ever not be an integer? Or do I need to convert this to strings all the time? Or do I, it just there's a whole lot of extra thinking that has to go on there. And frankly, having spent this long programming in both types of languages, I see not zero benefit. I don't see the bang for the buck in strongly typed languages. I just don't.
I frankly don't mind them. I mean, it's not that much of a cognitive load to say what type I'm going to use for something. So I don't mind it. The problem I have, at least with this implementation, I feel like it's a square peg in a round hole. It's kind of like Ruby, where I don't know, it feels like swimming against the tide to implement something like this.
Right. Yeah, I don't. The way it was implemented, I don't think is the best way to do it. Now, I will give props to the fact that they're not like forcing everybody to strongly type it. They're saying, hey, we've given you an option. So I'm good with that.
This is for these huge shops that are encountering these errors and they want to get rid of them.
Right.
So they're going to expend the energy to get rid of it, is my opinion.
Yeah, I think so. And it will take, if you're at a point where you're running into these kind of errors and issues, it's probably going to take a lot of energy and resources to start converting your stuff.
Yeah.
So, there is a big cost involved. Mark Clifton says, one good practice is when changing a type for a method, make sure it breaks all the way when you can't nail down all the dependencies use cases. That is absolutely correct. There should have been, like when that method was changed, somebody said, okay, we can't take an object anymore. It has to be a string. The first thing that should have been done in that method is, if this parameter is not a string, error.
Raise your hand.
Right. So now I will say that, in my opinion, this particular case was a case of bad engineering, not because we didn't have strongly typed language. But that won't take away from the fact that, had it been strongly typed, it would have saved me a week and a half of very late nights. So,
yeah,
credit where it's due. I'm not saying strongly typed languages are all bad. They do have benefits. I just never have seen them outweigh the additional costs that I've had to go through to implement them.
Yeah, and the thing about at least the Ruby implementation here, all they really did, at least with version 3.0, is just say, all right, here's a way to define your Ruby, the structure of your Ruby code. It doesn't even really do static analysis. You have to rely on other gems. Like, I think you can use sorbet, but I know you could use steep.
Mm-hmm.
So it doesn't even, all it does is allow you to define your RBS files. It doesn't do anything with it. You actually need to use another gem like steep that can then run against it and say, okay, hey, you have a method that's implemented here but not defined, or vice versa.
Yeah, in 3.0 they implemented the definition part, but not the checking part.
Yeah.
And what I've read is that 3.1 was supposed to start taking that a step further, and their ultimate plan is they will have kind of built-in type checking. I'm praying that that's, hey, yes, please turn on type
Optional.
checking, Mr. Ruby, or don't. I don't want it. And I suspect it will be. But yeah, I think 3.0 was probably just a step one. Let's dip our toe in and see what we've got. And I think they also knew that, hey, we've got, things like sorbet. We don't need to bake all this in right up front. But I think they could have done a much better DSL than a separate file. That's not enticing me to want to try it.
Yeah. Like I said, I mean, have a magic comment in there, and then now you have to, for that file, use types, for example. That's what I would have preferred.
Right. And I would actually there are a few cases where I would probably actually do that on a file. If I could say, hey, this file needs to be statically typed, there are some cases where that would be helpful. What I don't want is the language is statically typed always or never. That I don't like. That's, I think the happy medium would be, this file is statically typed or not. And I could make use of that.
And you could do it with this. So you could just write one RBS file for that, that one file. So you can do it that way.
Yes, you can, but separate file.
Yeah,
so
I know. Yeah. So I guess you and I both kind of like, bleh.
Yeah.
The separate file implementation. Yeah.
Right. And having the option now, even if I had the option, it wouldn't be used very often. But I can think of a couple of occasions where it would have been a helpful thing. So I'm not opposed to having the option at all. But in general, like all this blow up about TypeScript, and it's, the hottest thing since sliced bread.
Well, JavaScript, I
really.
think, needs a little bit more than Ruby does, frankly.
Well, JavaScript needs a lot of love in a lot of areas, but I don't think strongly typing it is what it mostly needs.
Well, it can. I think it avoids a lot of issues that Java, because JavaScript has issues, even more issues than Ruby would have type wise, because it's less. I can't think of the term. Um, you know, it's. I think it allows you to put whatever you want to in a variable, as opposed to Ruby eventually
Right.
says, okay, it's this type. And if you try to change it, you're going to get an error. JavaScript is like, sure, I'll take it, whatever.
Right. Well, that's the difference between like Ruby is weakly typed, Java is
That's what it is.
not
Strongly
typed.
weakly typed. Yeah, yeah. So, so I think people who want stronger typing, that may be a lot of what they're going to TypeScript for. So,
Right. But it's just, I just doing this so long, I just can't, I can count on one hand the number of times in 2 decades that I've said, oh gosh, I'm glad I had strongly typed in this parameter. It's not common enough to be worth the effort, at least in my
yeah.
experience.
Yeah. I mean, I think people gravitate to these languages that are dynamically typed because it's much easier to just, write the code, not have to worry about it.
Hmm? Well, I
But
can
then
tell
you
you
have all this code written and more engineers on there, and then you start having problems. They're like, oh crap, what are we gonna do?
right, and you're up at from 12 to 4 a.m. 3 nights during a week to fix a
Exactly.
problem. So, I mean, yes, it has use, and I do appreciate having the option in Ruby. I'm all for, hey, give me options without overcomplicating things. And I mean, I guess this separate file was their way to kind of let's test the waters without messing with anything we've got.
Yeah,
So, I mean, I get it,
I could. Yeah,
but it's just not, that would not entice me to try playing with it.
and it may be exactly kind of like I was saying. Is there are some very large Ruby shops that are gonna move to this, and everyone else will just not use it or use it sparingly.
Right.
So,
Yeah, I mean, frankly, I'm far more interested in the performance improvements of the 3.x series of Ruby than I am in the typing
well, that's
changes.
another discussion because you look at these performance improvements and it's specific gaming cases where it's like 3 times faster. Oh, give me a break. That's
Yeah.
just
Well, that was for
the
3.0.
fabric.
3.1 is actually moving because they were saying, yeah, we've improved performance for things that spend a lot of time on just a couple of methods, which are games, as opposed to things like Rails, which spend a little time in many methods.
Yeah.
So I think that's kind of their target for the 3.1 and 3.2 optimizations, or that kind of paradigm. But
Well, I'm kind of like, yeah, we'll see.
see, so
What I do want to talk about actually at some future session is the Ractor, so the Ruby actor, because I'm accustomed to using that as well, use that in lieu of threads, because I want to see what potential that holds, because that's essentially how Elixir works. It's all via, and uh, it uses actors for all of its concurrency. So I'm familiar with that. So I'm interested. What is the Ruby implementation like?
yeah, I'd be interested in that too. So next week.
I don't know about next week. Need more time, man.
Yeah, it's time. This past couple of weeks has been, I think, a little rough for both of us. Um, Trying to get a show ready in the midst of all that is a bit of a trick. But anyway, so I understand people who like strongly typed stuff. I'm not one of them, but you do you. So
And I'm more. I'm more flexible. I mean, if I had to choose, I'd probably stick with a dynamically typed, but I'm fine doing static as well. I just don't give me square peg round hole type thing where I think like I'm swimming against the stream type thing. So
Well, don't give me more context to switch into because my teeny tiny brain can't handle any more context switching. I've already got more than I can handle. So don't lay any more on me, thanks. That's the whole old dog new tricks thing, which I believe is false. Old dogs. Now, not this old dog. Anyway, hope you guys enjoyed that. If you did, please make sure and mash that like button and subscribe. Also, don't forget to join us on rubberduckdevshow.com, where you can see all of our videos and podcasts. Well, you can hear our podcasts, see our videos. Anyway, just go over there and sign up for the newsletter. Also, we're here every Wednesday night, except for last Wednesday, but every Wednesday night,
we're sick.
except when we're sick, at 8 p.m. Eastern for fun discussions like this. So join us live, or you can catch us on YouTube, catch us on the VODs on Twitch, or you can catch us on our website. Also, you can follow us on Twitter at @DuckyDevShow. See how bad I suck at Twitter. And we hope you guys enjoyed that. We will be back next week with a surprise topic because we haven't picked it yet. Anyway, until then, happy programming.
Happy programming.